Hey everyone, I hope you're doing well. I've got up here a rough design for my rock sliders. I'm going to be using 1 3/4 by 1 3/4 square tube for the main runner and the stringers from the main runner to the frame of the truck. Then I'll be using 1 3/4 inch outer diameter round tube for the outer runner and the kick out. Using square tube for the majority of them makes for easier manufacturing because I don't have to cope tube and then all the welds will be straight lines. For the same dimensions, so for example 1.75 inch square tube versus 1.75 inch round tube, the square tube will resist bending loads much better. So I used round tube for only the most visible parts on the outside of the slider, just for aesthetic reasons. I'll be using 3 inch by 3 inch 3/16 thickness structural angle to mount it all to the chassis. And the step plates will be custom laser cut from Send Cut Send, and they will be dimple dyed upwards so that we won't slip on the sliders when they're wet. And before we get too far into this video, I just wanted to let everyone know we had recorded this video with me holding the GoPro and talking as I'm explaining things out in the garage, but when we went to edit, we realized the audio is awful. So during editing here, I'm going to be voiceover. I'm going to do a voiceover for most of those segments. And that's going to be the format we use on the channel going forward. So bear with me for this video. It's going to be a little disjointed, audio versus video, and I'm sorry about that, but it'll get better next video. The material laid out here. The long piece of square tube is going to be the main runner, and then these two pieces of round tube are going to be bent into our kick out and our runner. So there's two sets, one for each. Over here, these are all pieces that are going to be measured and cut to length on my own. I didn't want to be that guy at the local steel yard. For these main runners out of the square tube, I'm going to include a 45-degree chamfer on each end. You can see me marking to cut that right here. I will plate over the opening in the tube, but angling the ends of the sliders will allow them to be dragged up and over obstacles easier if I have to winch or drive over them or whatever. For this project, I'm using all seam welded or hot rolled electric welded tube for this project. DOM, or drawn over mandrel, gets thrown around a lot in the off-road world, so I'll get into it a little. DOM is just a manufacturing method that involves cold working the steel, which will increase the yield strength through strain hardening. DOM has a yield strength of about 70,000 psi, while seam welded tube has a yield strength of around 40,000 psi to 45,000. So if you come up with a good design, seam welded tube will be enough for, bumpers, sliders, racks, skid plate frames, that kind of thing. You could build a roll cage out of it too, but almost all motorsport rulebooks require DOM for cages, so seam welded cages wouldn't pass tech. But for what it's worth, if I ever cage a rig, even just for recreational wheeling, I'd probably use DOM. For this project though, electric resistance welded will be just fine. Alright, there we go. Done for both sides. What I've done here, I want at least 7 inches of straight pipe before the bend starts. So there's 7. And then I've got every inch marked, another 7 inches, with the center of my bend right there. Basically what we have to do is bend a little bit, feed it through another inch, bend it a little bit, feed it a little bit, bend a little bit, feed a little bit. Another thing I'll mention real quick, this is seam welded tube, you can kind of see it there. So when I put this in, I will be using the seam as a rough gauge to make sure that it stays level as I'm bending it, and it doesn't want to twist one way or the other. Since that's a pretty good straight line, that'll make it easier. Alright, there we go. I'm just going to check this again. 0. Alright, about 2 degrees over. So this is a really picky bender to use, but there's plenty of videos online that you can go and check out about how to do it without kinking the tube too bad. To determine the overall length of the sliders, I took the wheelbase of the truck, for mine 130 inches, and subtracted 1 full diameter of the largest tire I intend to run on it, in my case 37 inches. So that gave me 93. From there, we subtracted another arbitrary estimate to clear the largest tire size at full steering lock, which resulted in an 85-inch length for the sliders for me. I then double-checked this by comparing to sliders for like a crew cab Tacoma, which has almost the exact same wheelbase, and there's lots of an aftermarket for it, and that 85 was almost spot on. All right, there we are. We get our runners angled, and we've cut out kickouts in the steps. So from here, I get to tackle this big pile of steel. Alright, we're a few days later. My laser cut parts came in. I used a website called Send Cut Send. We've used on our race car a couple times. Ordered these with just the holes laser cut in them, and I used my press here to do the nipple dies. Note on this, when I designed this piece in SolidWorks, I made the distance between each hole in each row enough to fit the dimple die, but the rows are too close together, so when I put the lower die on, it interfered with the dimples I'd already made, and it wouldn't make a complete die. So I had to get a little creative. I had to use whatever was laying around that was approximately the right diameter instead of the bottom half of the dimple die. So my SD card corrupted shortly after this point in the video, so in the stuff I lost, I just got the excess material on the round tube cut off, and I shortened the kickouts to the correct length here. I did that by just cutting it in half and sleeving the inside of the two pieces with a smaller diameter tube to help improve strength of the weld over just a butt weld. I also tack welded these main parts together and did a little trimming on the plates to fit them better. And then lastly, I cut and coped the short tube supports that go between the round tube and the square tube. Alright, I have all the corners of the pieces cut to fit the welds, and since every single one of them ends up a little different, they are now numbered 1 through 4 and site specific, so they are where they're going to go from here on out. And we're back. It's been a little while since I last worked on these. School's kept me busy, no excuse other than that. But in my nights, whenever I have time, I got all the plates welded on. Did that with the new MIG welder I bought, just the Harbor Freight, like titanium green one, 110, 120 volt. But came out really good. They're strong. The welds are a lot cleaner than anything my flux core could have ever done. So this will take paint and hopefully not rust, because we have, unlike the flux core, there's no dust on the weld. There's no slag, nothing that'll not bond with the paint and then later rust. So we're good there. Next step is going to be cutting our stringers to length, our legs, basically. All right. So we got all our legs cut. The 1, 2, 3, 4. The 4 main legs, I guess, are all 10-inch long, and then I just kind of eyeballed my measurements for the other 2. I wanted this leg to meet up. I didn't want it to be welded to this leg. I wanted it to be welded close to this leg on this piece of angle iron that's going to weld to the frame. And then I wanted it to come up as close as possible to this node, but they didn't have quite enough material, and I'm not too worried about that short of a length. This is fine, so it's going to sit just about like that. And then down at this end, I kind of did the same deal, as close to this node as possible. These ended up being, those ended up being 13 inches. These ended up being 16. same deal, as close to this node as possible, this join, but also, yeah. These are all our sections of angle iron that need to weld to the chassis. So half of them are, just as we'd expect. This is going to weld to the chassis. I shortened this bottom face of them because my frame rails are, I think, only 2.5 or so inches wide. There was a little overhang, so I wanted to shorten this so that I have a good fillet weld to make, that I'm not trying to do something weird. These I also had to cut out. There's a cross member mount that is shaped roughly like that, so when these go onto the bottom, I wanted this to sit nice and flat against a smooth surface, so I just contoured it around the weld for the cross member mount. That's fine. And these, kind of the same thing going on. In the front, my frame does a weird deal where it's lower in the front and then it swoops up a little bit. So I ran the cutoff wheel right along there and then cut a little notch and bent. So what I'm going to have to do with these is weld to fill in that and to fill in my notch, and then weld this whole thing to the chassis. For paint, I just used a Rust-Oleum brand spray-on bed liner, mainly because it's cheap and I can get it anywhere. It's held up well on other parts for me in the past and is pretty easy to touch up after it inevitably will get dragged over rocks.
Alright, last thing we got to do before we can position the slider and weld it. What I've done is I've taken my first body, my chassis mount bracket, I held it up to, used a clamp to hold it to the chassis, and just using the wire brush here, scrubbed away the dust where I need to sand the paint away for the weld to take. Alright, we got our 4 mounting spots all around the way, so I'm going to use the clamp there and hold them up, tack weld each one on, and then I'll come through and finish weld. Alright, so here they are, they're done, and it's been a while since I recorded the rest of that footage. So again, sorry for that. This is going to be like probably the worst video on my channel in terms of it being disjointed and jumping around like crazy, but the reason for that actually was that we had planned a wheeling trip for whatever, the Saturday of that week that I was finishing up welding them onto the chassis, and this, like most projects, this took a little longer than I thought it would, so ended up thrashing on it until literally the guys were outside my house waiting on me to finish this up for us to leave for this wheeling trip. So I mean, paint was drying on the way to the trailhead and everything, but yeah, they're done, and as you can see underneath here, we've used them. They've copped some abuse. There's a good one. So the 120 wall worked pretty well, but no, they've held up really well. They've saved my door panels, my rockers a couple times. I don't think, yeah, you can see there my weld plates onto the chassis have held up well. These turned out to be way overbuilt. I mean, it's a heavy truck, so I'm glad, but there's my chamfered ends. Yeah, I'm not super stoked on how that Rust-Oleum stuff has held up, although I guess there isn't much in the way of coatings that can handle being like constantly sandblasted every time I drive. but I was hoping for a little better results on it than this. So in the future, I'm probably going to try to, you know, maybe some marine prop paint or chassis paint or something that might hold up a little better. But for this video, that's how I put rock sliders on the old Dakota, and thank you all for watching.